I'm thrilled you guys are here, but seriously, guys, it's 5 o'clock. Don't you have anything better to do today than come to a deep dive WCF session? So we're going to be talking about best practices for building WCF solutions in the real world. We're going to be going deep into a technology, but we're going to go deep into a technology from a real world perspective. Everything that I'm going to show you are solutions that we know work with customers, are solutions that have been proven and patents in very large WCF implementations. So we're going to be tackling those real world patents and practices. I'm Jesus Rodriguez. I've been accused of having all those irrelevant titles. I'm chief architect with two companies, a co-founder, Telago and Telago Studios. Telago is a very fast-growing application development firm here in the United States, and Telago Studios is our sister software company. I also have all those little titles, and I do a lot of speaking, and so you probably see me on past TechEd and our conference. I also serve as an advisor to multiple product teams in Microsoft. That the only thing that means is that I get to collaborate in the design sessions of some of the technologies you're going to see today, and play with the bit very early on. So what are we going to do today? We're going to talk about, we're going to explore some of the challenges of WCF solutions in the real world. We're going to see some techniques and patterns to address that. We're going to spend a ton of time looking at code. We're going to spend a ton of time looking at Visual Studio. I don't have that many slides. So this is a 400-level session. We're going to be looking at code all the time, and at the same time, everything that you're going to see are real-world patterns. And I want to keep this informal. I want to, have a dialogue with you guys. I'm going to stop for questions, throughout the presentation, and I want to hear some feedback. Does that make sense? Now, I'm assuming that most of you guys are developers and familiar with WCF? Yes? Okay. Well, I'm all about services. If you hate code, if you absolutely hate C# and WCF, I think the aquarium is a very good option for you, or the Turner field, because we're going to spend a ton of time looking at code. We're going to spend a ton of time looking at in Visual Studio. Everything you're going to see today, again, is about real-world patterns. It's about practices that have been proven and that work, and that probably, if at the end of this session you can take every single demo I'm going to show you, you can take it and start playing with it as part of your solutions, I think I succeeded in this session. If not, well, you can blame Microsoft for coming up with this type of session. So for all demos, what we're going to use is that same scenario. A simple CRM system, two services, one service that handles account, one service that handles contacts, and different clients for different scenarios we're going to demo. Making sense so far? So if you're building service-oriented solution, if you're building services, here's some of the things that, regardless of the technology you're using, it will drive you crazy, particularly if you're using WCF. Versioning is a big problem. Having a way to remove dependencies between client and services, it always becomes an interesting problem. WCF configuration is the biggest challenge of managing WCF solutions in the real world. Yes or no? So the configuration is a problem of .NET. In general, WCF just makes it really worse. How to have highly available solutions, services in an intelligent way. Monitoring, always interesting, and identity and security. So what we're going to do now from the rest of the session is we're going to take each one of those points. We're going to take at least the most important ones, and we're going to craft it in a scenario, and I'm going to show you some solutions that you have today with the technology that you have at your disposal. Not technology you have to buy, not hardware solution, not software products you have to buy, with the bits you have today in WCF. We're going to try to explore how to address some of those challenges. Yes? Let's start with versioning. I'll give you a second to make sense of that picture. It's not pretty. Versioning is a big challenge regardless of the web service technology you're using. When you start building a service, we always assume that we crafted the right contract, we crafted the right design, and before we know it, we find ourselves making change to the service, and particularly if you live in the SOAP wisdom world and you haven't transitioned to RESTful service, you start affecting clients, and people have to regenerate proxies, and they want to hit you with a baseball bat, and people get really angry at you. So what are some of the strategies for handling versioning these days? There are tons of practices that you can read in terms of how to version XML schemas, in terms of how to version messages and all that. But at the end of the day, when you're dealing with a WCF solution, there is a new approach that we have seen being very successful, and is using that new technology. How many of you guys are familiar with the WCF routing service? Okay, so the WCF routing service is a technology that ships with WCF 4.0. It wasn't in 3.0, it wasn't in 3.5. It ships with WCF 3.0. That basically allows you to configure routing rules between different service endpoints. So you can position a single endpoint and then have different routing rules to distribute messages across the different endpoints. And the criteria you use for distributing those messages could be based on content, could be based on headers, could be based on the SOAP or WS addressing action. There are different criteria. So it uses a technology called WCF filter. So if you're working on creating different versions of the service, an interesting strategy these days is virtualize all the versions using the WCF routing service. So the client will send the message to that service, and you can scale that service. It's a normal WCF service. You can scale it with as you scale WCF service. And depending on the criteria you're going to use, the service will identify which version the message have to be routed to. What that allows you to do is that it doesn't impose a significant level of change on the client. From the client perspective, I'm still sending messages to this guy, and you use a routing service to start migrating clients to the newer versions. Does that make sense? Anybody deeply confused so far? So what we're going to do now, I'm going to switch to my VM, and I'm going to show you a demo of how to do that in WCF 4.0. So as I said before, for the purposes of these demos, we're going to be using this service, the account service. And suppose that service has two operations, get accounts and create accounts. And we're going to be seeing that throughout all the demos we're going to be doing. Now, if we look at the definition of an account, you can see that we have three fields: account number, amount, and creation time. Suppose that I created this service, I'm hosting it, it's working, and then somebody came and said, hey, you know what, we really want to add a new field. It's only one field, nobody cares, right? That we call expiration date. So we can create a new class that inherits from that account, and we add that property. Now, assuming that we have clients working with that new version, how do we start, distribute? We put together that new version, and how do we keep a single endpoint so the clients that are using the new version, the traffic gets routed to that version, and the ones who are using the old version, they still interact with the old version. Well, that's where the routing service comes to play. The routing service is a simple WCF service. And again, I'm going to show you a lot of code because this is a 400-level session. It's a simple WCF service, which contract is system.service-model.routing service. And the way this works is you configure routing rules. So I'm going to show you the rules I have here. I have two rules, both based on content. this filter type is telling me that it's going to use an XPath expression to filter the content. You can filter based on other things. There are tons of filters by default, and you can create your own. The message filter component that this uses is an extensibility point on the WCF runtime. So you can create your own. In this case, we're going to use one of the defaults that is XPath, and we're saying, hey, there is a filter if the expiration date is not there, and there is another filter if the expiration date is there. Now, we have also registered the two client endpoints, the two versions, right? This is version 1, and this is version 2. Notice the name, account service v1 and account service v2, because we're going to be using that. Then you define the filters, and then you have to define this thing called filter tables, because Microsoft couldn't make it easy for us. You have to define another thing called filter table that basically says if the message that comes in matches this filter routed to this endpoint, if it matches this filter routed to this other endpoint. Does that make sense? Yes? So now let's do this. I'm going to start 2 instances of the service. So let me pick this one hosting the version 1, and I'm going to start another instance hosting the version 2. And we're going to use that tool that I hate with a passion, but it's good for demos, that is called the WCF test client. And let me accommodate this. So I have 2 clients here, one pointing to without the expiration date, and the other one with the expiration date. But if we look at the config file of both clients, you can see that they're pointing to the routing service endpoint. And this other client is also pointing to the routing service endpoint. Now, and again, this was all configuration. I didn't write a single line of code to enable this. So I'm going to send a message without the expiration date. Uh-oh. Okay. Let's see. And you can see, don't bell on me. And you can see that this endpoint was invoked, and now I'm going to send a message with the expiration date. And you can see that the other endpoint was invoked, right? Does that make sense? So granted, versioning is typically more complex than, it could get more complex than just inspecting a single field on a specific message. But what I just showed you is how you can evolve the different versions of the service and add a layer that will allow you to decouple the selection of the version from the service itself. So you don't have to start forcing clients to migrate immediately. You can start saying, hey, you do your contract, you probably need to regenerate the proxy. Yeah, those things are going to happen. But then the routing rules, I'm going to keep it here so I can do it at my own pace. I know these new clients are going to adopt the new version, so I'm going to provision the routing rules. And it's not a one-to-one relationship between client and services. And the routing service is really lightweight. There is no code to write unless you're writing your own filters. So that component I show you, the XPath filter, there is an address filter, there are others, and you can implement your own. Unless you're doing that, it's all configuration. Does that make sense? Questions about versioning? Yes, sir. I'm sorry. Uh-huh. Great question. The question is, I'm new to the routing thing. No, the question is, can the filter table be done in code as well? Yes. You can provision. You can, if you don't like that XML file, you can write those rules elsewhere and write the code that from the database, for instance. Because it makes a great demo, but when that XML file keeps growing, you keep adding routing rules and routing rules and routing rules, it becomes a management problem. So you can provision it in code. Yes, sir. Yes. I'm sorry, could you repeat the? Yes. Next question. No. When you ask for the whistle, I'm still using the original one because I decided not to route the message exchange metadata request. So, because at some point, I could write a change in the contract that truly breaks the client. What I did this time was adding a field, which for the most part is a non-breakable change. But if I modify the name of the field, you're going to go back and regenerate the proxy. So that part still has to happen, but then I can accumulate the routing, the distribution to a different version. So to answer your question, you will point it to the original service. Any other questions about versioning? Oh, yes. You guys didn't come here to make this easy for me, did you? So what's the performance of using routing versus not using it? The routing service is really lightweight. However, if you implement your own filters, depending on how complex that logic is, at the end, it's another intermediary that you have to go through, and it could impose performance. Now, it's a WCF service, meaning you scale it the same way, you can distribute the load the same way, and you have all the IIS and WAS and App Fabric hosting mechanism to scale at your disposal. And I think there was another question. It's a good idea to put a version number in the data. There are multiple practices for that. You could write the version number in the XML schema. If you're using SOAP, the actual XML schema specification has a version attribute that most technology, for some reason, they chose to ignore. But it's there, so you can specify that. If you're using RESTful services, there are things that you can use in the URI. You can use it as an HTTP header. You can use it just based on content. But yeah, so there are a lot of scenarios on which passing the version number on the data, if you're versioning at the data level, is a good idea. If that's a unit of versioning, there is no good reason not to do so. Any other? Yes? Oh, man. If you already have an ESB that handles that version distribution, it seems like a duplicate function. Yes, the answer is yes, because the routing service is also a centralization point. The routing service, to that extent, it plays the role of message that routing role that an ESB technology will play. The thing is, the routing service is way lighter than all the ESBs I know, because there is no persistent mechanism. There is nothing. It's just give me the message, apply the rule, go out. Any other questions? So let's move to the next topic. I struggle finding a good name for this. But what we're trying to demo is this scenario. You have a service hosted on multiple endpoints. You're scaling that. You have 2-3 instances of that service running. Then clients are interacting with those instances. Then suddenly, one of those instances fail. And the client that was using that instance also goes down. And the reason being is because the address, the endpoints were hard-coded. Now, there are a lot of solutions for this. A lot of companies invest in very expensive load balancing technologies. The problem with load balancers is they have a lot of trouble handling some of the W-star protocols that you will use in WCF. So passing things like security, like WS-Trust and all that through a load balancer is nothing but a nightmare. And they have trouble scaling. So how many of you guys are familiar with that protocol, WS Discovery? I think Yuval did a short talk on that. No, you're lying. You all are familiar with. If you have used a printer in the last 2 years, you have used WS Discovery. WS Discovery is the protocol that printers, and it's funny, it's a protocol that was created by Microsoft, IBM, and all that, and it didn't go anywhere on the software world, and then the hardware vendors, they kind of adopted it. So when a printer gets plugged into a network, one of the modern ones, it starts broadcasting its presence. I'm here, I'm here, I'm here. This is my contract. This is the type of things I can do. And when you go to Windows and you say find printers, there is a message that goes out saying find me a printer with these characteristics. So those things are based on that protocol called WS Discovery, and it's using two messages, probe and match, on which, for instance, the client could say, I want to find a service that does this. Find one for me. And then similarly, the service can start broadcasting its presence. I'm here if anybody wants to talk to me. So if you have a service enabling WS Discovery, which is free with WCF 4.0, it's part of the framework, then you could have a client that dynamically resolves that. And when that instance goes down, it will find the other one. No load balancing, those services will scale the same way. I've seen applications of this working in very difficult scenarios like the military and all that because it's that lightweight. So does that make sense? Sort of? Yes, no? So what I'm going to do now is show you how this works with WCF 4.0. Let me switch back to the VM. And what I'm going to show you, I'm going to take the same service we were using, and we're going to enable WS Discovery. You're going to have to bear with me for a second because you have to write a lot of code to enable that. You have to add this configuration line to your endpoint. That's the only thing you have to do in WCF to enable a service with WS Discovery. When you do that, the WCF runtime said, hey, I have to inject the WS Discovery channel into the runtime, and the service start, I'm here, depending on how you configure. There are multiple ways, but it's only that configuration line. Now, on the client side, there's something else you have to do. That is finding the service. And for that, you can use this library, sorry about that ships with the framework, this discovery client, on which you tell them that you're going to interact with that UDP discovery endpoint because WS Discovery is based on UDP because UDP is a datagram-based protocol that could be, lightweight broadcasted to a network. And the interesting thing is that you can say, hey, I want to find me a service that implements this contract. You guys seen that? So what I'm doing here is I'm going to send a message out, find me a service that implements that contract. I'm going to take the first response. Let's see how this works, and then we're going to probably debug through it so you see it in more detail. So I'm going to start 2 instances of the service. And then I'm going to start the client. Let me accommodate these screens here. So the client is yellow, the services are green. When I hit enter here, the client is going to start searching for services. And it's really fast. My VM is a little bit. So it's going to search for services that implement that contract. It's going to find the first one, and it's going to invoke that. I'm not using any load balance. This is not a load balancing protocol. It could be that always find the same one depending on network proximity and things like that. So let me shut down the client, shut down this service, and now so assume that was my simulation of a service going down. Let me bring the client back up again. And now you're going to see that the client finds the instance of the service that is still running. Now, we traditionally make the mistakes of mixing discovery with load balancing. And those are two different things. I'm not interested necessarily on distributing load. I'm interested on discovering the endpoint at runtime without the need of having a registry, without the need of having a centralized metadata repository, which is another approach to enable this. But this is a protocol on which the services and the clients are constantly announcing themselves to the network. Does that make sense? I know there are a couple of people with questions. Yes, sir. The answer, it doesn't have to be. It does work even across the internet. It's normally I only seen it work in corporate network. Is UDP. So from external traffic, it might not be friendly to a lot of firewalls, but it's a datagram-based protocol. So as long as you're in the same network, you're fine. I mean, it's not per domain or anything like that. I would never recommend it so it's not an internet-based protocol, right? It's UDP. So it's an internal-based. Within the same corporate network, it works just fine. Yes, sir. So the question is, am I right about, if I tell you you're wrong, you're going to give me a low score? No. And am I right about the fact that you should not use this for a real-time application? This has nothing to do whether your application is real-time or more long-running. The step of discovering the thing is an extra step that you have to do. So if you're in the low latency, millisecond, microsecond type of thing, you probably shouldn't be using WCF to begin with. But whether the application is real-time or long-running, that's a service, right? How do you discover that service? That's what WS Discovery can help you. Yeah, WS Discovery is completely lightweight. I'm telling you, it's being used by hardware, by printers, and all that. It's extremely lightweight. If you look at the spec, the messages are tiny. It's just pro, fine, give me back. That's what the only implementation. The WS Discovery spec is transport agnostic, but really the only implementation that has been adopted out there is UDP because it needs to be that lightweight. So you could implement WS Discovery through HTTP, it just doesn't make any sense. Does the discovery happen at the time of the call? If you're building a WCF client, normally you would do that when you instantiate the factory, so all the channels. Assume that you're not gonna have that much of a bad luck that you discovered the endpoint when you instantiate the factory, and then when you create the channel, the endpoint went down. Well, you're bad. But normally at the factory level, it makes a lot of sense. Yes, sir. To enable that within a corporate network is normally fairly friendly to firewall is UDP. So if you can discover a printer across, you can do WS Discovery. You're doing it already. Yes, miss. Yes. Okay, great question. So if you have different versions of the service, if you have deployed on different environments, is my client on dev, in the dev environment, going to hit the QA thing. So that filter criteria, I'm actually going to switch to the VM to show you that. So this find criteria is not only the contract. You can specify a lot of things to filter there. This one is just the easiest one. So you can filter by environment name and things like that. Any other questions? Yes?
So the model, like in a real life crisis, the back certain steps that you watch for catch them, and that would be the case where you go back after you discover the finding.
I'm sorry, could you repeat that?
The model of detecting and determining when to do a new discovery
Yes.
would be just be certain paths, exceptions you watch for.
So how do you know when to do a discovery? So the easiest thing is, when you're going to instantiate the factory, but that's not necessarily true. It could be other patterns that when something goes down, you probably want to do a discovery and cache it. It depends on your app. What you need to know is that you can do that find criteria, discover the endpoint, and get back a list of the endpoints that are available. Normally, you could do that when you do the factory and then all the channels, like I was explaining the gentleman over there. All the channels that you create with that factory, use that endpoint. But probably you want to do other patterns, like do some sort of notification mechanisms or some sort of a ping mechanism. That is another thing I'm going to show in a second. Yes? Yes?
One more. If I was hacked, and I wanted to use this to put a service out that would indicate or switch into one, how much information would I use?
If I was hacking and I will put a service out so people will find me instead of the real service, you will have to know the contract of the service. You will have to know the implementation. You will have to enable WS discovery, and which most likely means you're in the WCF world as well, because it's really the only implementation. This is for WCF to WCF, most likely. And what you can do is the filter criteria. It could include a security key or some things like that. Any other questions? Okay, so let's talk about the exciting part. WCF configuration management. That thing is a nightmare if you have more than 10, 12 services. When you're dealing with a decent WCF application, you have two main problems. One, WCF configuration in and of itself is complex. So if you're a WCF developer, you want to enable certain capabilities, most likely you go to MSDN, you try to figure it out, and then you don't really know if you got the right one or the one that you read on somebody's blog. And then how do you enforce that? How do you communicate it to your other developers, to the people that are collaborating with you, so they can't reuse that and they don't go back to MSDN and find somebody else's blog? And now the second problem is when you move from one environment to the other, or how do you reuse that configuration? How do you change it quickly? I work on implementations with hundreds and hundreds of services with a team of full of WCF experts. And we move from one environment to the other, and we always screw up. Always something else. We miss one line. We deployed to 20 IIS server. We got 19 right. We forgot one line on the 20th. It always happens. Is that right? Or do you guys think that I'm smoking something here? So there is a pattern that I like a lot that is keeping that configuration in a centralized repository. Call it a database, call it something else. And then on the service side, enable a mechanism. Most likely I like the approach of surfacing that configuration as a RESTful service, and enable a mechanism which is called a WCF service host, that when it wakes up, it will download that configuration and reconfigure the service. The default service host uses the configuration file, so you can download that configuration file from somewhere else. And on the client side, you can use something similar called a channel factory. So you can apply this to tons of services. I just pointed to the same URL, and I'm going to show you that in a demo of how to centralize WCF configuration. This demo is fairly complex, so this is the part that you wake up and pay attention. So assume that I'm using this database structure for storing my configuration. Just that I have a service that has multiple endpoints that could have, this is probably the simplest database model I could come up with to model that. In the real world, it gets way more complex than this. So a service has multiple endpoints, the endpoint has bindings, and the endpoints could have behaviors, and also the service could have behaviors. And bindings have types like WCF, HTTP, and all the stuff. So suppose that I provision that database with a few bindings. Now here's the interesting thing. I took that database. Trust me, the database has some data. I don't have to show you that. I took that database and I built a WCF data service endpoint on top of it. You guys familiar with OData WCF data services? If not, I'm going to show you what that thing can do. So I took an entity framework model, that has the same structure I just showed you, and I built a WCF data service endpoint, right, that exposes that model plus a few modification things that I added to it to make it more easier to use. So I'm going to expose that. What that's going to do is I'm going to surface a WCF configuration as an HTTP feed. And I could do things like this, for instance. Hey, give me all the services, and that's going to return back an add-on feed with those services. The services I have developed, give me a specific service, right? It shouldn't fail, but we'll see. Services, service name, and let me see, give me the configuration for that guy. You can see this is the WCF configuration, but you're going to see it clearly now. Let's do ISO data, so there is a thing that called $value that actually gives you a field. So that's a configuration for that service. So I'm exposing that through HTTP. Now on the service side, I created this service host, right? It's a thing that inherits from service host that uses a class that is new in WCF 4.0 called the configuration channel factor, but we're going to see that in a second. This service host, when it wakes up, it makes an HTTP GET, downloads that configuration, and applies it to the service. And the service host starts when IIS starts, when the app pool starts, and things like that. So let me show you how that works. So I'm going to wake up the service. And I have a tracer here that is tracing, let me clear that out, it's tracing the entire communication it's proxying the entire communication between this service and the data service. So I'm starting the service, and you can see the HTTP GET was far off, and the configuration came back, right? The service is fully configured, up and running. Now, the client could do something similar, but using a mechanism. In the service side, we have a service host. On the client side, we have a channel factory. And a channel factory, if you were using WCF 3035 to build this, you have to write a lot of algorithms to interpret the configuration correctly. On 4.0, there is this class called the configuration channel factory. They couldn't come up with a worse name for that. Configuration channel factory that can read the configuration from another file. So my client, the only thing it's doing is downloading that configuration, saving it to another file, and telling this one, the configuration channel factory, go configure yourself. Now, let's look at how that works. I'm going to start the client. And when I press start, notice it's going to download the configuration, and then it's going to invoke the service. Now, kind of interesting, let me show you what are some of the things you can do with this pattern. This configuration, if you looked at it, it was using the basic HTTP binding. The endpoint was very simple. Suppose that I move from dev to QA, I'm going to secure the service now. I have another configuration that is using a secure endpoint. And let me show you how we can use that. On the service side, I'm going to go back here to the config file and say, hey, you're not going to use basic anymore. You're going to use secure now. Notice that that configuration file is empty. I'm going to start the service. And when I hit enter, it's going to do the HTTP GET, hopefully. Oh, my bad. I shut down the data service as well. My bad with that. So just to keep going, I'm also going to configure the client and point it to a secure endpoint. Notice that the client has no configuration. And let me start the configuration data service. And let me start the service. And let me start the client. And you're going to see what happened now. So on the service side, when I press enter, it's going to download that configuration. But you're going to see that that configuration now has a security binding in it with all with a certificate credential. So it's not basic HTTP anymore. I just went from unsecured to secure by changing just the name of the service. And when the client will do the same, and hopefully it won't fail, and it will invoke the service. So it resolved the endpoint, the entire configuration, and granted, to do this in the real world, you need way more than that. But it's the pattern of centralizing and exposing it out and using channel factories and service hosts. It simplifies, so it allows you to reuse that configuration. Does that make sense? Yes, sir. Are you caching that? As I said before, to implement this in the real world, you need things like that. Right, that's one. You don't want to be doing an HTTP GET. Granted, on the host side, the host only starts when the app pull or something forces to start. It's not every call, right? And the same with the channel factories at the beginning. All the clients that you instantiate with it will use the same configuration. But caching and all that will happen if it's down. And the database model I show you doesn't quite work. There's scenarios that you need more than that. I mean, it's very simple for the purpose of a demo. Any other questions about this? Does it make sense? Yes? Yes? The first question is the configuration channel factor, the one that comes with WCF. Can I get a specific sections of the configuration? The answer is, it depends. So what you can do is you download the system.service model section and apply only certain sections like behaviors and all that. But what happens is it's going to look for services and all those things. And if it's not there, it's going to bump. So what you normally do, you have to merge it with other things that you have in another config file. When you use it, it has to have everything. Okay. Any other questions about this? Okay, so service availability. This is another name that I struggle trying to find something that really illustrates what we're going to see. You're working on an application. You deploy a number of services to production. Then suddenly one of those services starts. People think that it's not working correctly. Nobody can really tell you if it's not working correctly, or it goes down and nobody really knows. And how do you know that a service is active and is working and all that? We do that in networking all the time, and it's called ping, right? You ping a service to know that it's there. This is not WS Discovery that you go and find a bunch. This is, I know who I want, but I don't know if it's working correctly. So a lot of times applications fail because of that, because you're invoking an endpoint that is really not available, it's not performing correctly, and you have no recovery mechanism for that. So wouldn't it be nice if you could do a ping for WCF services without having to execute the service? Yes, no? So there is a mechanism that has been there since WCF 3.0, since the first release, called Operation Invoker. How many of you guys are familiar with that? Okay, so let me try to explain it. I know the WCF runtime, the service runtime, is called the dispatcher runtime in the WCF terminology, has a lot of extensibility point. When a message comes in, the first thing that executes is called a transport channel. Then there is a component called encoder. Then there is a bunch of protocol channels. There is message inspector, parameter inspectors, a bunch of things. The last thing that executes before the service executes is called an operation invoker. So you could implement a pattern on which you implement an invoker and that accepts a ping message. And the message is going to be intercepted before it invokes a service, but after the entire WCF pipeline was executed. So you know security is working, you know transport is working, you know encoding is working, any other junk that you plugged in for monitoring and all that, all is working. But you don't execute any logic and return back a ping result. Make sense? So I'm going to switch back to my VM, and we're going to do a demo of how this mechanism works. And we're going to debug through it so you can actually see it end-to-end in action. The way you implement an operation invoker in WCF is you have to inherit from this class called you have to implement this interface called iOperationInvoker. And iOperationInvoker has a few methods. The one that you really care about is called invoke. This is whether you invoke synchronously or you have this too if you're going to invoke asynchronous. If you're using prods like BizTalk Server and all that, that always use an asynchronous mechanism to invoke WCF service. You will end up using the two below. For the most part, you're fine just implementing invoke. Now, the syntax of invoke is incredibly simple because what it takes as the parameters are the instance, the object, which is the service instance that is going to be invoked, and the parameters. And that's a synchronous one. The synchronous one is the same. I'm sorry, that's invoke and where's? There you are. So here it is. It takes the instance, it takes the inputs and the outputs that it's going to return. That's a synchronous one. So what this thing is doing is actually intercepting the message and returning back, hey, I'm here. Very lightweight, but I know everything is working. I'm not executing any business logic. Now, on the client side, there are multiple ways to plug this into the WCF runtime. The one we find really easy to use is writing this thing called a channel extension, which is basically an extension method to every channel. And we like this syntax, right? So you can do client.innerChannel.isAvailable with it's a generic with the type you're going to pass, and that's going to return true or false. So that's the only logic you have to do. Is available. If it's available, I'm going to call it. If not, I'm going to do something else. So let me show you how this works, and then let's debug through it so you can actually see it in action. I'm going to start the service. And I'm going to start the client. And the first thing this thing is going to do is say, hey, it's going to determine if the service is available. They say, hey, it's available, big deal, right? Now, if I shut down the service, and I'm actually going to enable this breakpoint, so you see it working. If I shut down the service, can you guys see that all right? So we instantiate that and we said it's available, and it's going to find that it's not there, and then it's going to say it's not available. Now, let's go back and see what happened if it's available. Let me start the service again, and I'm going to enable a breakpoint, let's say on this invoke operation. So I'm going to start the service, and I'm going to start the client. And when I press enter, so same thing is the client is gonna execute, and the invoker is called on the server side. Notice that's the invoke method, and notice that the input of that method are the parameters I pass, and this is a service instance. You can see is you can see it's our account service. So this thing is going to return back, but it's not going to invoke the service. So it's intercepted right before the service is invoked. But at that point, you know that the rest of the WCF runtime is available and performing correctly. Does that make sense? Yes? No? Questions, comments, personal attacks? Yes. No, I'm calling this service. Yes, let me switch back. I'm calling the service. So the client code, so this inner channel thing, if I run through it, this inner channel thing is the service, is the proxy. Now, on the service side, you implement the invoker, and then you plugged in that invoker using a WCF behavior. This is the way it works, right? You implement, it could be a service behavior or an operation behavior, depending on what level do you want to configure that. In this case, we're doing both. And what you're doing is you add that behavior, and the behavior adds the invoker. So right here, the behavior will say, it's gonna be hard to maximize, but the behavior will say dispatch operation dot invoker equals pin invoker, and that's injecting the thing into the WCF runtime. Any questions about this? Yes, sir. Anytime, no, not for monitoring. Anytime you want to determine if the endpoint you're going to talk to is available before you call it, or anytime you're going to diagnose, at some point somebody say, hey, it's not working properly, let me ping it. When do you do ping to a server? Isn't that before you're trying to do something, or when something is not working, you want to make sure that it's available? It's the same thing. You're not going to get a timeout exception if you use my code. If you use the channel extension, it will catch all that and tell you it's not available, and this is why. Yes? I'm sorry, could you repeat? Uh-huh. No, the question is, if you update the proxy, do you have to recreate the extension method? Not at all, because it's a channel extension method. So every channel, independent of the service you're using, can use that extension method. There was another, yes, sir. Can I combine this one with WS Discovery to do crazy things? So you can use WS Discovery for discovering availability, and you can combine it with this to making sure if the specific endpoint you want to talk to is available. Any other questions? In the scenario that you're combining the two, yes. So if you use the two, obviously WS Discovery will tell you. The thing is, using it the two, they both play different roles. If you're using WS Discovery, you already have a number of endpoints available. Now, suppose that you have those services in production and somebody tells you, hey, something is wrong with this, or the endpoint is not available. It's just to do a ping to a specific endpoint. You can still find everything. The extension method won't interfere with any of that. All right, so let's talk about monitoring, which is always a nightmare. How many of you guys are using the Windows Server App Fabric? Oh boy. So the idea of monitoring is one of those things that we always want to enable in WCF services. I want to make sure that I know which messages are going in or coming out. Normally, until the Windows Server App Fabric, we have had to implement a lot of mechanism for that, and there are crazy solutions using BizTalk Server BAM and a bunch of that. WCF enables a tracing mechanism, but it traces to files unless you extend it to capture those traces and create your own database and all that. Microsoft released last year the Windows Server App Fabric, which takes tracking and persistent mechanism from what was Windows Workflow Foundation at that time and brings it to the WCF world. So you can configure a WCF service for being monitored, and you can surface that information from IIS. Now, how will this work? Normally, the client invokes a service, that thing is configured, it goes to the event tracing, the ETW, the Windows ETW, and then it gets stored in a database. And then there is an IIS plugin, an IIS console extension that you can visualize that information from IIS. There is a little problem with that. At some point, somebody thought that it was a great idea not to track the messages itself, just the event, that this thing was invoked, this thing was respond, this service respond, and then there is a lot of scenario in which you actually want to see the data. Right, so what I'm going to demo are two things. One, how to use a normal Windows Server App Fabric, what's the experience, how do you configure, what do you get, and how do you extend that to incorporate tracking the message from the normal Windows Server App Fabric without having to use any other tooling. Does that make sense? So if you're hosting WCF services, you're going to be using the Windows Server App Fabric because it's going to become the default way for Extends IIS and WAS for a runtime optimized for WCF services. So we're going to demo that now. I'm going to switch to my VM. And it's really simple to use a Windows Server App Fabric. I'm going to use the same service we have been using until now. Oops. What did I hit? See? Okay, cool. I was saying we're going to use the same service we're using until now. And what you have to enable is this thing, the ETW tracking. That's what you need to enable in order to start capturing the information. Now, that service is hosted in IIS because for the Windows Server App Fabric, in the Windows Server App Fabric, you have to host it there in order for the information to be tracked. Now, here's experience, right? You get this when you're in IIS, you get the dashboard that it will show you metrics about the service. Experience is similar to what you normally get if you were using BizTalk Server. So I'm going to run a client that interacts with that service. So the client is just going to invoke that service, and it's going to print something to the screen. Now, given that I'm monitoring that, I'm going to be able to see some information about that message exchange. and hopefully that works. So it got some data back. That information is being logged using this mechanism, the event tracing windows. It's a mechanism that sits at the Windows kernel level. It's what Windows uses to pipe messages between different processes incredibly fast. We have done load tests that we're tracing 200,000 messages per second with 4% of CPU. So it's ridiculously fast. So it logs to the ETW, and there is a Windows service that runs, that takes that trace, and store it in a database. And you can see it here. Is the Fabric event collection service. That thing has to be running. So if I go back to the to my Fabric console, that thing doesn't like when you do refresh, so it's going to take a second to tell me that there is one message. You can see that there is a message, a new instance here that completed. You can see that this is a service. You can see all the events that you got. Let me remove this thing because it's a stupid filter that doesn't allow me to see a lot of data. So you can see all the events that the transport was executed, all the stuff. If you're using WCF tracing, these are the same events you get. Now, what is not here at any point is the actual message itself. You can see the message, you can get metrics, you can go back to the dashboard and gather all the analytics. You can throttle stuff, you can stop, and all that is for the IT Pro is great because it's embedded into the IIS 775 console. And for that, the only thing you need is a Windows Server Fabric. You don't need anything else. Now, when we have started using this, the first question you get from the people using this information is, where is the message? I mean, I get a problem, I see an error there. What do I do with it? Where is the actual message itself? And there is no mechanism on the App Fabric at this point for tracking messages for WCF service. There is something for workflow services. So we built, for the purpose of this demo, I built a thing. It's a dispatch message inspector in WCF, which is another interception mechanism that uses the ETW, uses this class. So it intercepts every message coming in or going out of the service, and it uses the ETW libraries to log the message. Now, here's the interesting part. If we look at the message inspector, this thing is extracting the contents of the message. It's extracting the contents of the message, and then it's saying to the lower, hey, log all you're going to log normally and pass this message payload. So in order to do that, you plugged in that inspector as part of a behavior, right? Message tracking behavior. You add it there, right? You add that inspector. And you add that inspector here. So you said dispatch runtime message inspectors.add your inspector, and you enable that via configuration. Let me show you how that works. I'm going to enable tracking of the message now. It's the same behavior I was using before, but now I told hey, track, notice the order, right? Track everything you're going to track, and please add my poor message payload there so my IT Pro people don't hate me when I give them this tool to use. So you enable that, and I'm going to rerun the client. And now, when we go back to the App Fabric, and this thing decides to refresh itself, it hasn't refreshed yet. Remember, it logs first to the ETW, and this information, what that dashboard is surfacing, is what is already in the database. So you see there is a second record there? That was a second event that happened. We can start looking at the details. And I'm going to remove that filter again. And when I run the query, let's see. Let's see what we got. Message details, and look at what we have here. It's the actual contents of the message that was sent. I didn't change the tooling. I didn't force you to use a news report. I'm using IIS, the same monitoring tool that you would normally use with the App Fabric, and now we're tracking the content of the message. If you're interested in knowing how that App Fabric database looks like, given that this is a 400 level session, it looks like this. So it has only this set of tables, and the view that you truly care about is called App Fabric WCF event. That view is the one you care about, and let me prove it to you. If I execute that query against it, that's what's storing the contents of the message. So that comes with the Windows Server App Fabric. It's an extension of what was there before with Windows Workflow Foundation. And it's going to get better because this is going to become the default way of hosting WCF services and workflow services, and Microsoft is investing a lot on that technology. Now, you can use the default monitoring experience, or you have other options. You can use that and extend it with that message tracking mechanism and any other things that you want, or you can just create reports against the database that visualize the information in a friendlier way, because let's face it, that IIS console is not exactly the most appealing thing to be using, but it's what you get by default for free. Questions about that? Question? Yes, sir. No, when you install the App Fabric, you configure tracking, that's a database you get. That's the default database that comes. I didn't add any table, didn't add any view. It has an extensible model that has a bunch of columns for adding other stuff like my message.
What do you need to run that? We have Windows 2008
You're good with that. It's a free download. You run it. It's a free download from Microsoft. You execute that. It's going to ask you to configure two. There are three things in the Windows Server App Fabric. Persistent for long-running WCF services and workflow service, tracking for monitoring, and caching. So when you install that, it's going to tell you what database you want to use for tracking, which database you want to use for monitoring, which one for caching. The mechanisms, if you don't like that database, and trust me, there are people that don't like that database, the mechanism is extensible. So there is a thing called tracking participant that you can implement to track the data somewhere else. You don't get the dashboard experience anymore, but you get all the interception mechanisms. And yes, sir. Can you use the App Fabric if you're hosting the WCF in a regular Windows service? No. You can try to use the libraries to log directly to the ATW. Now, remember, with Windows Activation Service, you can host the other transport. A lot of the reasons why people wanted to self-host WCF service was because IIS was only HTTP. With WAS, you can host MSNQ and TCP and all that in the WAS runtime that you can surface from IIS. The same, so you can host a TCP service, and the App Fabric makes it even better. The App Fabric gives you that always running experience. There is a thing that is called always available services or something. That is the same Windows service experience. It's a service that is constantly running. Any other questions? Yes, sir.
Your program, you show the services running in a command line kind of operation. Can you back them into a real Windows service?
Yes, you can. The console app makes a great demo. You print stuff to the screen and people believe it's working. But it's not. And no, you can take the same services and host it in IIS, host it in WAS, host it in that Fabric, self-hosted in a Windows service, the same mechanism we use. So the thing is, Windows services don't make cool demos, and console apps do. Any other questions? So here are other challenges that will drive you insane, and you have to consider, but I only had an hour to do this. So security and identity management is huge. Windows Identity Foundation is a way to address that these days. If you're modeling identity of users or doing authorization and all that, WIF, it extends WCF and makes it way more flexible to model those type of things. Service dependency modeling, how do you describe if a service is calling another service, how you describe that? The answer to that is you need a domain-specific language to model that dependency. So when people change stuff, they know what they're going to break. Interoperability remains a challenge. Governance, how do you manage and govern WCF services? There are tools out there for that. Testing is an interesting one. So how do you do unit tests, system integration tests, or how do you do load testing? With WCF service for load testing, again, there are tools out there, LoadGen and other tools. For system integration testing, yesterday on my other talk, I demoed workflows using Windows Workflow Foundation for doing integration testing, like choreographies across multiple services, which is something really hard to solve. That's a tool that, a technology that might help with that. So in a summary, adopting WCF is a very flexible programming model, but with flexibility comes complexity. So adopting WCF in real-world solution brings a lot of challenge, like availability, like discoverability, like configuration management. The key to every single demo I did is, the key to that is WCF extensibility. The WCF runtime has more than 20-something extensibility points. Each one of the capabilities I demoed today is using one of those. WS Discovery is a channel. The PIN is an operation invoker. The tracking is a message inspector. Configuration is a service host. So everything that we enable extra are extensibility points that you plugged into the WCF client or dispatcher runtimes. And again, when you're building an app, you cannot enable all this day one. I mean, all this is based on things we have seen out there. You have to start small, find what makes sense to you, take some of those patterns and refactor it, adapt it to what really makes sense to you, because this is not a silver bullet for every solution. Start small, iterate, and improve, and try to apply those patterns as you go along. With that, I would like to open for questions. That's my contact information. I have to tell you that my life and my companies and all that depend on the fact that you filled out those slides and those scores and give me good evals. No, I'm kidding. Don't forget to fill the evals. It's a good thing. With that, I would like to open for questions. Yes, sir. Yes, the code will be available on my blog probably end of this week or beginning of next week. Any other